we have done the introduction, the pace of relationship, which is the pace of relationships. Just to recall, we have the relationship between weight to weight relationships and also the volume to volume relationship. Okay, that one is the basic parameter or the basic characteristic of the soil, which is we need to know uh, the moisture content, the density, the unit weight and so on. That one is the basic parameter yang you all kena tahu bila we want to start our design of the geotechnical structure. Okay, so misal kata you nak design foundations, nak design nak buat slope stability, nak buat retaining wall and so on, you need to have at least that basic parameters. If you don't have the weight, moisture content, you tak ada unit weight, you tak ada density, you cannot determine the soil bearing capacity. Okay, sebab based on the soil bearing capacity, you akan determine the stress, you akan determine the strain. How to get the strain, how to get the stress adalah daripada nilai-nilai basic yang ni lah. Okay, yang daripada pace relationship ni. So dia berkait-kait. Okay, alright. So now we go to the particle size of soil. Actually, we already touch sedikit berkaitan dengan particle size distribution, which is the famous method that we use is sieve analysis. Okay. But before this, I already mentioned that in the class that we categorize two type of tests in order to determine the particle size distribution. Apakah method tu? The first one is sieve analysis. Another one is what?
Hydrometer.
Hydrometer. Good. Okay. How do you differentiate type of soil for hydrometer and the type of soil for sieve analysis?
Kalau hydrometer dia find soil grain, dia
Okay.
find soil. Kalau sieve analysis dia coarse soil.
Okay, good. Alright. Coarse grain soil and also fine grain soil. Kita ada gravel, kita ada sand, kita ada silt, kita ada clay. Gravel and also sand, we categorize it as coarse grain soil. Okay, ingat ni. Gravel dan sand categorize sebagai coarse grain soil. Coarse grain ni so kata yang kasar. Okay, yang kasar. Fine grain soil termasuk adalah silt and clay. Clay and silt categorize di dalam kategori di dalam fine grain. Okay. So, alright. So, we go to the particle size distribution. The first one is, saya punya, okay. Satu, kita ada sieve analysis. Actually, bukan yang ni. Sepatutnya, okay, kita ada coarse grain dengan fine grain. How do you determine the coarse grain soil, okay, partikel yang berada di dalam coarse? Kita akan menggunakan sieve analysis. When we conduct the sieve analysis, at the end of the mesh tu, dekat tray yang paling bawah sekali tu, kita ada pen, which is that pen is tak ada mesh, dia memang pen lah, okay, pen. So from that pen, we will proceed to the hydrometer analysis to determine how many silt, how many clay. Kita akan tengok pula in detail still. Okay. Okay, so sebelum ni pun saya already shows the standard that we normally use. Okay, ini adalah comparison between four system of standard untuk describe the particle size of soil. Okay, so kita ada silt, kita ada sand, kita ada gravel, and kita ada clay. Ini batu ni. Ni kategori can be rock sebenarnya. Okay. So, untuk clay silt, this one is kita punya fine grain. Untuk sand and gravel, we consider it as a coarse grain. Okay, so yang famous is USCS, ASTM also lupa saya. Okay, ASTM, okay, and also kita selalu akan guna JKR standard. But JKR standard ni dia tak banyaklah table-table yang you boleh refer menyeluruh. It's more to the procedure macam mana untuk handle that earthwork, nak handle untuk kerja-kerja pengorekan and so on. Okay, so ini adalahnya. So kalau this one is the log system. Okay, the log grain size dia akan dalam logarithm lah. Okay, so bila you nak determine the particle size of distributions, you may use the log graph. Okay, log graph tu nanti you akan dapat S curve from the log graph, so you can determine fine silk ke, medium silk ke, coarse ke, and so on. Alright, so if you can see here, there is the graph of particle size distribution curve. Okay, the distribution of particle size or average grain diameter of the coarse grain soil is based on the particle size. The main is you need to know the particle size based on the sieve analysis and also the hydrometer. Okay, obtained by screening in known. Sometimes we are using the screening, sometimes we are using sieve. Okay, known weight of the soil through a stack of sieve of progressively finer mesh size. Okay, the important yang you kena tahu in this graph is the term of poorly graded, well graded, gap graded. Okay, maksud kata kalau graph ni kenapa kita consider is poorly graded? Why we consider this line of graph as a poorly graded? Because you go back to the pace relationship. In pace relationship, we have solid, we have water, and also we have air or we have a void. Kan? Kalau misal kata that sample only have this range of size ataupun satu jenis size sahaja, means that void dia adalah banyak. Ataupun air boleh memenuhi ruang void tu. That's why we consider it's poorly graded. Okay, tanah musuh utama dia adalah air. Terlebih air, dia akan jadi musuh. Okay, so well graded means that there are variety of size. Okay, variety of size. Daripada range lebih daripada 10 mm ni sampai ke 0.01. Means that ruang-ruang void yang ada akan dipenuhi oleh silk, sand and so on ni. Maksud kata air bukanlah takkan, air akan minimum untuk memasuki ruang-ruang void di dalam particle-particle of soil ni. Okay, that's why the distribution of size dengan variety of size particle ni, dia akan memberikan good graded ataupun well graded of the soil sample yang kita collect tu. Okay, gap graded ni ni lah dia akan mungkin dia akan terlebih size yang besar, terlebih yang tu. Tapi yang the best one is you need to have a variety of size particle di dalam sesuatu sample tu. Okay, maksud kata kalau poorly graded for this case means that untuk ni dia ada satu size je. Dia ada satu size je. So dekat sini bila kita zoom out, dekat sini dia ada void dia. So this void kalau hujan, air akan masuk. Bila air akan masuk, the strength of the soil ataupun water content increase, the strength of soil akan decrease. Well graded pula, kita ada size besar, kita ada besar. Dan sampai kat sini size dia kecil. Dia memenuhi ruang-ruang void ni. Okay, dan sampai kat sini dia makin halus. Dia akan tutup lagi, ruang lagi. Okay, so air, water kurang berpeluang untuk memasuk kawasan particle of soil tu. Okay, Boleh faham konsep of graph ni? Kalau saya keluarkan ni, please describe and explain the graph of particle size distribution curve. So you lukislah ini, you sketch lah graph ni and then you explain lah apa maksudnya. Dia adalah daripada phase relationship punya kesinambungan. So here is the sieving analysis. So we need to have a set of mesh and also the pen. Yang ini adalah pen kan. Yang ini yang coarse grain lah, untuk coarse grain. Okay, and then yang ini adalah untuk fine grain.
Obtain a representative field sample of aggregate. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. After drying, cool the sample to room temperature. Then record the dry weight.
Here is the dry sieve analysis.
Ensure that the sample size meets specification requirements. Stack the sieves in order with those having the largest openings on top.
You need to follow the procedure berus tu kena pastikan. Betul.
Transfer the sample to the sieve stack without loss of aggregate. Hand sieve the sample or use a mechanical shaker set to the
Shaker
calibrated
kita
time.
tak macam ni lah. Shaker kita macam dalam gambar yang first tadi.
After sieving, remove each sieve from the stack. Move trapped aggregate from undersized openings. Empty each sieve and record the weight of material retained. During this process, check for overloaded sieves. Note that individual or cumulative weights may be recorded, and the method chosen will affect subsequent calculations.
We have a standard table, so you need to fill up all the size, all the retained weight for each mesh.
Use a soft paintbrush to clean finer sieves. This will prevent damage to the more delicate screens.
Penting you kena brush sebab nanti bila you nak total up, dia tak sama dengan nilai berat yang you timbang awal dulu. Dia mungkin akan hilang sebab your particle akan terselit-selit dekat mesh tu. Lagi-lagi mesh yang halus ni. Okay, so how do you analyze the result from the sieve analysis is you will use these equations. Okay, before we develop a particle size distribution curve, you need to analyze first. Okay, so we need to consider that Wi is the weight of the soil retained on the sieve. Means that kalau sieve satu, berapa size dia, kita kena timbang. So, dia sebagai W1. Sieve number 2, berapa dia punya size of opening, and then kita kena timbang W2. Okay, so for each sieve, misal kata kalau kita akan ada guna 7 sieve, means that 1 sampai 7 lah dia. Okay, 1 hingga 7. Divide by W. W is the total weight of soil. Okay, total weight of the soil times 200. So you akan dapat percentage retain of each sieve. Okay, then how do you determine the final sieve? You tengok lah, dia akan kumulatif. Okay,